Okay, so username to go to Tinkercad would be juniortechfusion@gmail.com, and password would be juniortechcapital and #1. There you go.
Hi guys, how you doing?
Hey, Emily's joining us for Arduino.
Yeah, Alex, can you check the other room and see if anyone's waiting there? Hey, Emily, how you doing?
I cannot check. I need to be in this meeting. If I switch, everybody gonna get lost.
Okay, can you send the people whom we don't see the correct link? Because they might be actually using the...
People sending? Okay, so let me resend the invite with this one. Hopefully it will be correct. So
yeah,
I'll just switch.
need to fix that bug there.
The parent class has started, Zoom meeting, ting, 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 and I'll go to electronics with kids. Here it is.
Whom are we missing?
Will, from the first glance that I see.
Yeah. And?
William is missing, and I think everybody else is here. Ian is here, Kranti. Okay, let me just wait. Okay, this is all sent.
Let me see what it says now. Hopefully the correct one now.
Signing sheet. Let me see. Ajwad is here.
Yes.
Ajwad's here. Ayan.
Yes.
Ayan's here. Dhruva is here. Ian's here. Katerina is missing.
Okay, Katerina, yeah.
Katerina is missing. Krant is here. Ricardo is here. Rylan is missing. And William is missing. 3 people.
Yeah, can you send just to them at least the correct link?
I'll send to everybody.
Yeah. Yeah, now it says Arduino, so I'm not sure what was happening the other two. Yeah, now it's correct link.
Hi, Emily. Comment ça va?
Ça va bien. Hi, guys.
Okay, so let's wait for them to join, and we'll start with going through what we learned yesterday.
I have actually trivia prepared here, so it's better to do the.
Just wait, Alex. I want because Will and Rylan, they're kind of behind.
Yeah.
I want to make sure they're catching up. They're not missing anything. But I have a fear that they actually followed your Unity link and they're waiting there. So. Can you maybe open that Zoom meeting with the Unity link, and if they're there, redirect them?
It wouldn't go. You tried it, right? So it went to
the meeting isn't open, right? So like,
oh, right. Yeah,
it
said that the host is on the other meeting.
Mm-hmm.
Yeah.
Alex?
Yes.
So I was running my LED, right? And it flashed once and it's not flashing again.
Huh, okay. It flashed only once.
Yeah.
Maybe on setup.
Did you have a resistor?
Yeah.
There might be a couple of issues. There might be issue with the code that it prevents it from working past first cycle. Just need to troubleshoot that, and so try to press the button on the Arduino board. That there's a little button there. If you press it, it will reset the code. If it still flashes once, well, somebody's calling. Maybe that's the lost personnel. Hello, this is Alex.
Once I'm waiting for it to flash again, though.
Maybe you check your wiring properly.
Hi, Chris. Yes. Can you check this second email we just sent? There was the template mix-up there on the mailer, and the meeting invite went with the different class. So if you try use either yesterday's email or the one that just sent last minute ago.
Yeah, I think all my
that should have a correct one. Yeah, we're not starting waiting for you guys. Bye.
Okay, and can you call Kate maybe? I think there also might be lost.
Who? Oh, okay, never mind.
Check Katerina. Maybe you can follow up with her. Just go on the dashboard, look for the email and send them the correct one.
Okay.
Yeah.
And let's see who's gonna come, because that probably was William's step. So, Ayana, did it work after you press the button?
Yeah, it worked once and it
Yeah,
flashed
so
once.
then we eliminate the problem that the LED is burnt. So if it blinks at least once, it's not burned. So you need to go look into your code. Open up the Arduino. If you want to share your screen, I can stop sharing. You can show us.
Okay, let me share.
Okay, I stopped sharing. You can share your screen. We'll all take a look at it.
Host disable participant screen.
Ah, did I? Okay, let me see. Advanced sharing option. All participants sharing. Go, try now.
Previous turn to see it. Yep, I got it.
Okay.
And
You got pin 13 as an output, digital write high, delay, digital write low, delay. Everything works, supposed to be blinking with interval of 1 second. And your LED connected to pin 13 or to pin 10? On your board.
Oh, pin 10, yeah.
Ah, your code calls for pin 13, so switch it.
Oh, okay. Okay. Yeah, now it's working. Thank you.
Yeah, no worries. Hi, William.
Hello.
Hello. Yeah, I'm sorry for the mishap with the link. We're still trying to troubleshoot what happens there. So we're missing Rylan and Katerina then.
Ryland's here with William. I'll get him signed in separately though. Too.
Ah, okay, okay, good. Okay, so you guys gonna share one laptop, or are you gonna get him signed too?
We're gonna just get him signed in too.
Okay, perfect. All right, then I'll go ahead with the quick review now, and we'll hope that Katerina will join us. Everybody can see my screen?
Yes.
Yeah, I can see it.
All right, yeah, so let me just also bring the participant screen in front of me so I see if somebody joins so I could let them in. And I'll bring the chat window here too. And we're recording. Yes, we're recording. Awesome. All right, guys, so let's quickly just go through some of the concepts that we covered yesterday and see if we remember some of them. So who can tell me what will writing low out on the pin connected to LED do?
it'll turn it off.
So which option there between the four
B.
options? Turn the LED off. Yeah, that's correct. So low meaning basically saying the same as cut electricity off that pin. That's correct. Okay, find an LED here. Super easy.
A.
Of course. What's the B?
A is the LED.
What's the
B
B?
is the resistor.
A resistor. What is the C?
Some type of sensor?
Yeah.
We didn't cover it. We didn't cover it yet, but if you're curious, you might have looked into your box already. Try to do the who's who there.
A button? Sorry?
It's not a button. It's called potentiometer. So it's a kind of variable resistor. So when you turn that knob, the resistivity between the center pin and two outer pins changes. So this is the device that is used in stereos to adjust the volume, or in your kitchen mixer to adjust the speed and things like that. We'll be using it today as one of the variable sensors. Today we're going to be covering sensors, and that would be one of them that we will cover. And this is an analog sensor. All right, what does this sketch do?
A.
Any other opinions? Oh, here's Katerina. And now we have everybody.
So you need to connect your wire to 10, and that's the output. So I need to connect it to the Uno circuit board.
Yeah, the answer was correct. A is correct. Yes. So basically, the void setup function is the function that runs once in the beginning of the sketch when we just power up the Arduino, and inside that function, we're setting up some of the parameters for our pins. We're telling which pins we're going to be using as inputs, which pins we'll be using as outputs. So in this case, pin 10 would be used as output, meaning that the Arduino will not be listening to it, but rather will be turning power on and off. Sound good? All right.
Yeah.
Question number 5. Which command delays LED by a number of milliseconds?
Delay. B.
All right, sounds good. So how many milliseconds are in a second? If we want to have the LED blink every second.
1,000.
1,000, that's correct. Yes, we were using 1,000 value, and if you want to make it like a half a second, then how much we need to put?
500.
500. Yeah, perfect. Excellent. Okay, which command is called repetitively over and over again as long as Arduino has power?
Loop.
Loop.
A.
Yeah, everybody's correct. It is loop, yes. Setup function, as we covered, number C is the one that is only set running once, and number A is loop, and it's running over and over again. Okay, well, this is the kind of a complimentary question. Which command is called once when the program starts? Everybody should know by now.
C.
Setup, exactly. All right, this is the window of Arduino IDE that we're using, and which section shows you the line number our cursor is on? A, B, C, or D?
B.
B doesn't show the line number.
Oh, D, sorry.
D does, yes, exactly. So let me just bring up the window here. Actually, if there's a function there in the IDE to enable line numbers, and that's easier on the code to troubleshoot. So if you run on your sketch, you can see those line numbers. Why is it important? Because if something is wrong, you make an error in your code. In the lower part of the window, Arduino IDE will be swearing at you in a red bold font. And that swearing usually will involve some sort of location of where the problem is. And it's quite handy to have those line numbers so that you could see where you made a mistake.
So
okay.
one sec. So I noticed that a lot of similar students are answering, but for next time, can we actually send the answers in the chat? So have students write their multiple choice response in the chat so that everybody gets a chance to answer?
Yeah, good idea. We'll do that. But we'll run through our trivia for today for now. Okay. And I will go ahead and we will introduce something new for this class. So what are we going to be going through today?
Yes, I'm sorry, Alex. Before you go there, I want to make sure, from yesterday, I noticed the confusion was about the Tinkercad program. The Tinkercad is just a layer there. You don't really need it at all. You just need your Arduino set and Arduino IDE that will push the program there. Why we use Tinkercad? Just to test our ideas, to kind of create a prototype, see if it works, and because it has the easy Scratch type visual programming there, right? So for you guys, it would be very hard to actually type the code in Arduino. That's why we introduced that intermediate layer, the Tinkercad, okay? So the only thing you need to understand right now is that Tinkercad is just to make your life easier. All you need is Arduino, and Arduino IDE pushes the code to it. So whatever Tinkercad produces needs to be exported, then opened with Arduino IDE, then pushed to your Arduino code. So that's a flow I want to reinforce because I think that wasn't clear from yesterday. So first thing first, if you're using Tinkercad to test your idea, good. You can do that because you can actually see if your idea works or not. You can see if your code works or not. But ultimately, whatever Tinkercad produces need to be exported. The code from Tinkercad needs to be exported. And Alex, can you quickly show us again how to do that? Because I think that part was unclear yesterday.
Sure. Yep. Let me quickly log in to the Tinkercad here.
Like the professional big boys and girls, they don't even use Tinkercad. They just have their Arduino, and they have their Arduino IDE where they actually program. Like our FLL team, for example, they program directly in Arduino because they know programming language. But for you guys, for those of you who are beginners, Tinkercad make your life easier because it allows you to actually put the programming code as a puzzle. But that's a necessary piece. So step one, you actually wire your Arduino. You put everything there. You can do it directly on Arduino if you are pro, or you can test your ideas on Tinkercad. Step two, you need a code that you're going to push to Arduino. And here's the trick. If you're using the code to control your Arduino, then instead of ground, that negative side of your circuit has to be connected to some pin output, right? And Alex, can you show all the pin outputs? Can you just explain the board also? Just to here, just so that we see what is on the board.
Yeah, of course. And also the Tinkercad is very useful when you're trying to show other people how the circuits is built, because otherwise I would have to show you, you know, things like that, which is very difficult to make sense of because wires are all tangling and it looks like a little hedgehog or something with all the needles sticking out of it. The Tinkercad allows you to have very tidy schematic with all the lines running to the pins, and you can use it and zoom in and out and show it very up close. So I really like having this tool around. But guys, you, as Rada said, you don't have to use it. Once you know the syntax and once you know how to code, all you need is the IDE to push the code in.
Yes, and just to explain this part, like yesterday we actually discussed the circuit, the plus and the minus, right? So the plus is basically takes the electricity out of your voltage. You give the power to your Arduino kit using your USB cable. You connect it to computer, so the power flows from your computer, right? It flows through the 5 volt or 3.3 volt output, right? And then it goes, does a job on your Arduino board, on your circuit board, on your breadboard, and then it goes back and it flows either to the ground, or if you're doing something programmatically, if you want your light blinks, if you want any logic, if you don't want your breadboard, whatever contraption you did on that to be stupid, if you want it to be smart, instead of ground, you're choosing one of the pins to output your code because your program will go and actually control that pin, right? So, and how many pins do we see right now on the Arduino board? You can see they're all nicely lined up on right side, yes? Will, can you tell us how many pins you see that we actually can program, and when we write our code, we can actually put the output to go to that pin? They're all on your right side. How many pins do you guys see? I see 13, right? Alex, am I right?
Yeah. Oh, yeah. Yes.
Yeah? I see
14
13 pins.
because there's a 0.
Yeah.
14
well, 14 with 0, yeah. And some of them, Alex, can you explain? Like some of them have interesting signs in front of them. Like 10, for example, it has some dash-looking sign, or no, not dash, but like wiggly thing in front of it, right? So does that matter or not?
Well, we shouldn't be concerned with that for now. We will cover that what we're going to be doing, the hardware interrupts and things like that. So for now, all we need to be paying attention to is the pins on the left with the A letter and pins on the right that are digital. So since we will be introducing sensors today, and we will be working with analog sensors, we will be connecting them to this part in here. So, yeah, question?
Whoever needs a question.
Go ahead.
I need help. I was building, while I waited to get on, I was building some Tinkercad device thing, and I forgot how to get out of the Tinkercad things to leave. so I can get into
To leave the Tinkercad, you can click on that Rubik's cube there
No,
on the
no, no,
left.
I don't think he means leave. Do you mean like how to get the code extracted from
Oh
Tinkercad?
yeah, I will cover it. I will just wanted to first let me just run this. I will explain what analog means and what digital means. So if you look at the
I
kind
want
of
to leave it.
I want
What's
to
that?
leave out of this.
Oh, you want to close Tinkercad, right?
I want to close this one little.
The one that he built.
I want to make a new one.
yeah, just click on that Rubik's cube and you will go to main menu, and from there you can create new ones.
You see on the very, can you show Alex which Rubik's Cube you mean?
Yeah, that's the one that has Tinkercad written on it.
The logo, the Tinkercad logo. If you click on it, you'll just get to the main page. Yeah?
Yeah.
Okay, so, and just Alex, before you move on, I just want to really quickly recap also. So after you connected your board, the next step you do, I want to make sure they understand the entire flow, right? The next thing you need to think which code you're pushing on Arduino, if you connected it to either digital or analog pin. And as Alex said, all those 13 pins are digital. That's where we connect LEDs. But he's going to introduce you to the concept of analog pins today, because those are used to connect the sensors, and those start with letter A, and those are on the right side. But that is later. Then what does your code do? Your code will control that pin output, right? How do we do that? We click here on the code. Alex, can you help, please? Yeah.
Okay, guys.
Can you click, please, on the code, Alex? Yeah.
I cannot. I am in an annotate menu right now.
Oh, okay.
I was about to do something.
Oh, please, Alex, can you just quit that? I want to make sure they actually go through entire flow, because I think there was a lot of misunderstanding. I spent an hour with Katri after that, with Kranti actually, to explaining the entire flow. Okay, so you gotta code your code here. By default, it comes like this: set build an LED. You want to change that, okay? You can't just push this code because it won't do anything to your program what you want. So once you build the code here, and again, this is just like a scratch. It's just like puzzles you put together, and you just have to follow Alex or just look into the project that he created. After this, what's the next step? Who can remember from yesterday? Yes, Ayan?
You need to download the code.
Right, you need to export the code from here. How do we export the code, Will?
You like plug it into the chip and press the arrow.
The arrow button. The arrow button, it won't push it directly to the board. It will just create a file for you that you can open with Arduino IDE, right? So go ahead, Alex, push on that. Yeah, assuming that this code is correct, which is it is not at the moment, but once you push that, go ahead, Alex.
I did. I pushed it, and there's an
and there is a file right that appears at the bottom, right? So go ahead and open that file. You have to open that file with Arduino IDE, and here's one more trick that you all guys to remember, which also wasn't kind of covered yesterday, or was. Okay, so go ahead, open that Arduino IDE. If you lose it, you can always click on its symbol at the bottom there. Yeah.
I actually prefer to go to the text in here and copy it from here, because in here you can see right away how your code's going to look.
Okay, that's another option. So one way or another, you need this code to be opened with Arduino IDE, right? So you can either click it directly on your file, or you can actually copy paste the text. Yeah, you need to know the both ways. Now, can you actually open the Arduino? I want to cover the port part.
Okay.
I've got a question. When
Yes,
I download when I press the download button for the code, it doesn't download it onto the Arduino.
No, it doesn't. That's exactly my point. You guys need to understand that it only creates a file that you need to open with Arduino, right? So it's like when you download anything from internet, it just creates the file in the download folder, but you then need to open that folder and actually activate the file, right? Open the file. So once you click on the file, it will open with Arduino. So there are two methods. You can either do it that way. You can either like click on the file that you just downloaded to open it with Arduino, or you can copy paste the text like Alex just showed directly from Tinkercad to Arduino, which is probably actually a safer way, because sometimes I've seen people to click many times to download the file, and then they have 2 or 3 copies, and then Arduino get confused, right? So probably the safest way is like Alex prefers, to actually do the text. Alex, can you show one more time how you did the text, how you switched to the text mode?
Right here, when it says blocked.
Yeah, so
There's
right now you see
there's also text.
Right, so if you select the text, then you just select this code, you copy, and you open your Arduino IDE and paste it. Ultimately, your goal is to actually have that code opened with Arduino IDE, because Tinkercad doesn't communicate to your physical Arduino. Only your Arduino IDE does, okay? Want to make sure you guys are clear on that. And just one more trick I want to cover, because that's a mistake I see very often. People forget to check the port part. Can you, Alex, open please the IDE? Yep, there you go. So here, before you can push this to your Arduino, you want to make sure that your program communicates through the same port where your Arduino is connected. What does port mean? Those USB openings on your computer where you actually connect your Arduino device called ports, right? So, well, they connect to the correct port. So here in tools, guys, make sure everyone pays attention. This is one of the very common mistakes we see. Here in this port, you have to make sure you select the port that actually says Arduino Uno on it. You see, Alex has COM1 port and COM2, or COM6, right? COM6, right? So which one he needs to connect this program to?
The port.
Which COM he needs to select? The one that says Arduino on it.
Yeah, Arduino Uno.
Which is COM6, right? Yep. So
Yeah.
that's a step you guys all need to make sure you're doing, because otherwise you're just sending your program to nowhere, right? You need to make sure it actually goes through your computer through correct port and goes all the way to Arduino. Just same way we did with Lego Mindstorm devices. If you guys were in our class, same way there, right? You have to make sure you're selecting the correct port. And then the very last step from here, you're actually physically pushing the code to your Arduino device. And that's a button, the second button there that Alex just shows, the arrow button, that will download your code to Arduino, and voila, your Arduino will right away start working. Just so that you don't get frustrated with this process every time, of course, Tinkercad helps, because you can test your ideas there, okay? So if your idea worked there, but it doesn't work on Arduino, you understand that, okay, maybe some wiring was done wrong, and you just can follow your schematics and do that. Just want to make sure that process is clear, because I saw a lot of confusion about that yesterday. And is that clear to everyone?
Yep.
Yeah, okay, good. I want to make sure that we're good on that front before we go into more complicated stuff. Good, Alex, sorry about
I have something to say.
Yeah, any questions? Yeah, good.
In my computer, copy paste doesn't work.
Copy paste.
And when I copy paste, it just doesn't want to do it.
Well, if the keyboard doesn't work, try right clicking and selecting it from there.
Yeah, you can select the stop, right click your mouse and select copy from here.
No, it just that what I can copy paste it, but when I try to run it, it just doesn't want to run it.
In this case, you need to be getting the error here on the bottom and just read what the error says and try to find it. Because like yesterday, I noticed when I was sharing the code in the chat, people were pasting it underneath the default. So if I, for example, go to the new window and have this, and then you're trying to take the code that I'm sharing and you paste it in here like this, you're going to end up with the trouble. If I try to compile it right now, I'm going to have an error. You see, it says redefinition void loop. That means that there was another one already and you created one more that is unnecessary.
Yeah, that's not what I did. I deleted the first void loop and I put that on, and it just didn't want to run it.
So do you have an error?
I had an error.
You
But
want to
when-
share your screen? Maybe then we can.
But
be
when
more-
I did the exact same thing with by typing, it works perfectly.
Okay, Ricardo, how about we give Alex opportunity to introduce the new topic, and after that we'll send you and team to the breakout room, and he'll look at your code. Okay?
Okay.
Yeah.
Okay.
Oh, yeah, there may be different reasons there, Ricardo. We'll troubleshoot it in
Yeah,
each
we'll
particular
troubleshoot it,
case.
don't worry.
Yeah, it might be some like a stray comma or something, any syntax element there that makes it problematic.
And Alex, before I let you take over, guys, I just want to make sure we have 1 hour break between this class and the next class. So yesterday we actually used that hour to help and troubleshoot, to help those students who are struggling. Like I personally spent about actually 40 minutes with Kranti walking her through the process again. Do not leave the class after that. I know the class is 2 hours, but we're here. We want to make sure you guys are all getting the knowledge you're here for. So if you have any gaps at all, please stay. When we say goodbye to everyone, we're still in this room for for some time, as much as you need us until the next class starts. Okay? So this is your opportunity to stay and bring your questions and get help. Is that clear? Yeah?
Yep.
Awesome. Thank you. Okay, go ahead, Alex. Sorry for hijacking.
Okay, where were we? Yes, we will be introducing the analog sensors today. So the analog sensors that are part of our fancy kits, what we have there, we have potentiometer, that guy. What else? We have a temperature sensor. I don't know if it's part of it. We got photoresistor. So if we have time today, we're going to use at least 2 of this. We will use potentiometer as a variable input and the photoresistor as a variable input. And based on that variable input, we will be controlling one of our LEDs. We will find which parameter we want to control. I'm thinking about controlling how fast it blinks based on the value that we read from one of those variable inputs. So I will just show you quickly how the analog and digital are different. So I will make a quick, let me make like a chart, 2 charts here. I don't know if it's too small probably on your screen. Let me exit this, take these guys away, create a little bit more white space. And I'll go back to annotate here. So if we to connect the digital sensor to Arduino, we are going to see encoded messages that are looking like this. Those are the pulses of electricity from between 0 and 5 volts. So this is the 5 volts here. So it cannot go anywhere in between. It's either 0 or 5. When we go to analog, it's like temperature, right? Temperature doesn't come in discrete values. When you put your water to boil on your stove, it goes from cold to warm smoothly, and then like your weather outside of the window. It's cold in the morning, then it's hot during the day. So your electricity chart might look like this. Okay, so this is analog. So if you turn the knob on your stereo and your maximum value here would be 5 volts, it can go anywhere between 0 and 5 in a smooth gradation. And that's the main difference between analog and digital. And when we look at our Arduino board has specific area to connecting those analog devices that have smooth readout. And among those, as I said, potentiometer. That's the one that we're going to be using first. So I will use the Tinkercad. You don't have to. I will just show you how we're going to connect it. And then I'll show you how that device looks, and we will connect it actually physically on your breadboard. So let me rotate this guy like this, and I will plug it into the breadboard somewhere in here. And how this guy works is that we're going to connect outer legs, 1 to plus and 1 to minus, like this. I will make this guy red and this guy green because it's connected to negative. How come this guy is yellow? this guy to +5 volts. Make it red. There you go. That's how our schematic gonna be looking. I remove second LED for now to keep it simple and not confusing. And we're gonna be reading the center leg of that potentiometer, and we're gonna put it into the analog port, and I select the analog 0 like this. So that will be our schematic for today. So we're gonna be spinning this guy, and we're going to be reading the value of that resistor using that LED connected to analog 0. What we had so far in our IDE from yesterday is this code. We were having our LED blinking on connected to pin number 10. We had digital write 10 high, then we were waiting for 1,000 milliseconds or 1 second, and then we were turning it off, and we were waiting for another second before turning it back on. And it was running over and over again. Today, we're going to make this value, instead of hard-coded, this value will change with the value we read from the sensor. So as you turn your nubbin on your potentiometer, this thing's gonna change. And of course, frequency of blinking of our LED will also change. So that's gonna be pretty cool. I'll show you how this potentiometer looks, because in your kits it's slightly different. Like before, Arduino were packing potentiometers in package like this, right? In your kits, it's tinier. It's this little guy, and actually it has the main pin disconnected from it. So it's like this guy. Do you see?
Where in our kits is it?
It has like 3 legs on the bottom, and it has a little pin that goes into it. I found mine in the right bottom compartment. So if you open up your kit, like this, it would be right here. Those background replacements really makes it funny.
Yeah.
So are we supposed to be following along?
Yes, you don't do anything in Tinkercad, but you take
is it tiny?
It's kind of small. Yeah, that Drew was showing the correct one.
Yeah,
yes,
because well, thanks to online class, you guys all see actually the schematics. You don't need to create your own. Okay, guys, you just follow Alex's schematics and build the physical Arduino.
I may have already done the schematics.
That's
awesome.
The one.
Great. Yeah. Yeah, play with Tinkercad on your own time a lot. That will actually, because then you'll see what works, what doesn't. But the beauty of online class is that Alex's screen actually shared with everyone. So that actually helps to, you don't need to build this again in Tinkercad. You can just follow his schematics. Because ultimately the entire reason to do that in Tinkercad is to actually test if that works or not. Is that it, Alex?
No, Katerina, this is not it. The one that you're looking for, it's more of a kind of a roundish guy like this.
Oh, okay.
Okay.
So is it supposed to have?
Yes, Drew, that's correct.
10K on it?
Oh, that's tiny.
It is tiny, yes. Yeah, the earlier versions had big guy like this.
Does it say 10K on it?
This guy says 10K, yes.
Yeah, 10K.
And where do you find the photo sensor?
Photo sensor in a little plastic bag. There's a plastic bag, and there are 2 of them in there. There are several buttons, 2 diodes. One look like a temperature sensor, if I'm not mistaken, and 2 illumination, the light sensor.
Yeah, it's this one.
Also, guys, your potentiometer, in order to spin this guy, you need to attach this little thingy in the middle of it. It's also inside your kit. So find that little spinny thingy. It's like a plastic thingy with a little hexagonal pin on the end, and you'll be able to plug it in there, and it turns into this. Yes, Dhruva, that's correct. That's the thing.
Wait, which
Is it in the
compartment?
Is it in the bottom left corner?
Bottom right corner is where I
Like
found the
this?
potentiometer, and the pin was in a big compartment, I think.
Like this?
Yeah.
Yeah, exactly, Ian. That's
Good
perfect.
job, Ian. Yeah. So we have 2 now.
Kranti, did you find yours?
I found the training.
You found the pin. Now you need to find the actual thing.
So it's black round.
Ah, yeah, that's not it.
Or is it this one?
Not that. Not this one either. No. Look, this is how it's supposed to look in the end.
Oh, found it. Okay.
Yeah, I found the thing that I was looking for.
Yeah. But Alex, take it apart so that they otherwise they'd be looking for the combined one.
Why do you plug it into the breadboard though?
Okay, I found the best way to plug it is to plug it in the middle with the one leg on one side of the gap. Yes, Catherine, this is the adjusting thingy. Now find the other place, other thing that it goes into. And the 2 other legs on the other side. So let me find the breadboard and I'll show you how I connect it. Okay, this is how I suggest to put it in.
So one.
Right in the middle, spanning the gap. So 2 legs on one side, 1 leg on the other side.
I can't find it.
It won't fit in.
Yeah.
No, it does. Oh, what are you trying? What are you trying to plug, Ian? Can you show me?
Is this thing?
This thing?
No. You plugged it from the wrong side. You need to plug it so that the legs are on one side and pin on the other.
Oh, okay.
Oh.
It's not coming. Oh, ow.
Be careful. Don't puncture your fingers.
Yeah, I did it. Okay.
Do I need to like put
Like
the thing that we did last lesson back in? I was a little late. So
You will need to assemble it like I show right now on a screen with LED, 1 resistor. The LED legs goes into the pin 10, and then we will have the potentiometer going to A0.
all right. So the side of 2 metal.
Alex, take a look at Ian's one. Is that correct?
Where does it
go on the board?
does the side on the 2 metal?
No, Ian, that's not how I would recommend to put it in.
Okay.
You need to have access to each leg individually. So if you'd like not to use the breadboard, let me see if we have like a female connector here. So-called. No, we don't have female connector. So yeah. So the same way as I put it here for the in the Tinkercad, plug it the exact same way. We have 2 legs on one side, and this leg will actually end up here on the row 14, like this.
Oh, I see.
Yeah.
Okay, let's move on. I want to make sure they all got that. Ian, your background, because you're sitting against the window.
Yes, Ajwat, it's correct.
Makes it hard to see.
Oh, okay.
Yeah. You don't have any blinds that you can lower, right?
Yeah, I can pull it down.
Yeah, please do.
There is pretty much only one way to be used so that you could put it standing across the gap on the breadboard. There is no other way. It will not go any other way. So it can only go with the 2 legs standing on one side of the breadboard and a single other leg on the other side of that gap.
Yeah, I just want to make sure they find the right device. Was that the right device that I showed you?
I don't know. I
Does the
didn't see
blue
it.
cord go exactly on the 3rd stud?
Yeah. So if you, for example, plug in it in row 50, the single leg will go in row 50, and like the outer legs will go row 51 and row 49, but on the other side of the gap. So if you put it,
one?
yes, no, this is a buzzer. That one has 3 legs. Buzzer has 2 legs.
And also, guys, your Arduino kit comes with a little paper. Alex, can you show that paper, and can you show that device on the paper? maybe then they can actually figure out better. Yeah.
Yeah.
Paper?
Here.
Yeah.
The
So there
on
you
the on the
go.
on the on the cover of the box. Let me.
Take off your background. Yeah. Take off your background. You don't need a background. You have a nice, beautiful picture there.
Is this how it's supposed to be?
This is tiny.
That's the correct device? Yeah, looks like the device, right?
It is tiny. Yeah. We are tiny. Yeah.
Yeah, push it out.
Okay, do you see
There
my
you
finger showing this guy here?
Yeah. You guys pay attention.
That's the one. If you have your Arduino kit, you open up the lid. On the lid, there is an insert that has all the elements that are inside your kit. So your potentiometer is this
on the
guy.
third element from the right. Okay?
Yeah, next to that 7-segment display, and it's called potentiometer 10K.
So now, yeah, now when you find it in your kit, make sure it looks just like that element on the paper, right?
Okay, so that's good.
Wait, does the pin go on top?
Difference of 11.
No, the pins have to be at the bottom and the knob should be on the top, right?
Yeah, the knob. I meant the knob.
Yeah, the knob.
Alex, do we connect the wires?
If you
yeah, you plug the potentiometer into the breadboard, and then you need to connect the outer legs to a positive and negative bus on the breadboard, like I showing here.
Okay.
And the center leg will not be connecting from here. In your case, it will be connecting from the other side of the breadboard, but in here, I have to do it here. In your case, it will be going from here to the A0, okay? Like that.
Oh, because that leg is actually on the other side.
Yes,
right?
that leg will be on the other side for them.
Guys, remember, electricity on your breadboard doesn't flow through the gaps. So if anyone, if anything happens on the other side and it has a gap in between, you need an extra wire to actually bring the electricity between that gap, okay?
Yeah. So guys, please remember, for you, it will be connecting like this.
Yeah, just show it like that, because that's exactly what they have. Yeah. Yeah, just keep it like that too. It's easier. So the idea is that we will use the knob to dim the light on and off, right, Alex? Am I getting it correct?
And it will be controlling the frequency of blinking.
Oh, okay. Got it.
Yeah, because with LED dimming is very interesting. You can't really have it smooth.
Okay.
There's extension wire.
So Ian, you connected, right?
Yeah, I don't know if it worked.
No, it will not work until we program it. So we didn't get there
you
yet.
don't
We
have
will be
the-
programming it.
using the old.
Can you like show us how you put the potentiometer in again?
Sure. So it's the same way as I physically in.
Can you unplug it and plug it like right in front of the camera?
No, it's really hard to do it there like this. So you see it has 2 legs on that side and 1 leg on this side. I need to get a second camera and with the zoom.
Yeah, like that looks down actually. Yeah.
Yes.
You're supposed to follow along, right? Like on Zoom, you're supposed to follow along?
You're supposed to follow along with your physical Arduino device. So your goal right now is to assemble this contraption that is on the Alex's screen on your physical Arduino device. So skip the Tinkercading step.
Okay.
Yeah.
Do I have to place the wire, the blue wire?
Well, it can be any color, but color coding does help. Yes.
Is it blue? No, the blue wire. Do I have to put it on?
Yeah, you have to put it on, but it can be any color wire, right?
Okay.
So if you don't have a
What
blue
about the
wire,
LED? Do I need to put on the LED?
Yes, yes. You need to put everything right, like on Alex's window. Yeah.
Okay.
Yeah.
So are the two legs facing on the side, like, are they on the side where the LED and stuff are?
Yes.
Like, so there are 3 legs. You said that one of them goes on one side and the other 2 go on the other.
Other 2 go on the other side of the gap, yes.
Yeah.
Actually,
Yeah, but like, are they on the side where the LED is, or are they on the other side?
It doesn't matter.
Oh, I need the diagram back.
Okay, so this is how you need to connect. You see there's a gap, and in here there's your potentiometer. So 2 legs on one side and 1 leg on the other side. You connect 2 legs to negative and positive, and in here there's some chip. You ignore it. You connect the middle one to the pin A0. Here it is.
Yeah, that's better.
Just keep it here, Alex. Yeah. Okay.
Alex, doesn't matter how, like, when you plug the wire into the positive, right?
Yes.
Doesn't matter how close the wire is to the legs.
No, as long as they're in the same row, you can connect to any hole into the same row, and it will be the same, no matter.
Okay.
Now I need it.
Okay, Eduard is asking, where do you find the photoresistor?
Photoresistor is in a little plastic baggie like this. And
what's the button?
And it looks like a little pancake with a snake on it.
Hey, where do you find it in the box? I mean.
Oh, in the box.
It's on
the plastic bag was I think in
the bottom right.
Yeah, in a small compartment in the middle or the left one. Just lift this stuff.
I didn't touch the middle. It was in the left one because I definitely did not touch the middle and I found it. So
plastic bag, Ziploc bag like this with several buttons in it. It's hard to miss.
Okay. Thank you.
Okay. Wait, so we'll try to use potentiometer first.
No,
make sure everything works, and then we will switch potentiometer for the photoresistor.
Alex, Ian shows you. Is that the one?
Yeah. No.
No,
Ian.
It looked like the chip.
No, the one that.
Am I supposed to?
It has smaller pieces in it than that. Yes, that's the one. Yeah.
Am I supposed to code it right now?
Not yet. Not yet. If you know what to do, you can. But I will like to actually introduce.
Alex.
Yes.
This one.
Yeah, that looks like the one.
That's the one. Yeah.
Yeah.
Okay.
The photoresistor isn't on diagram yet, though.
No. Guys, don't take it out yet. Photoresistor will be second step. So for now, we only play with the potentiometer.
Yeah, let's program this one first.
Connect everything like it shows on a screen. So we have.
I'm almost done. Don't worry.
Just one LED with the resistor.
Guys, give us yes in the chat box if you're ready to move on to coding. Okay.
Wait, so you want me to take out the other LED?
You can keep it if it doesn't confuse you. You can keep it. If it's too many wires, then take it off. Kranti, did you find everything, or are you still looking?
Then
you found?
Yeah.
Cool.
Yeah. And everyone show us your breadboard like this so we can actually see once you're ready. Okay.
Nice.
I got it.
Yeah.
Okay, Katerina, the center pin has to be connected to pin 10 on Arduino. So your center pin is not connected, right? You need to put the wire on the other side of the gap where the leg is.
It has to be connected to pin 10?
Yes. But the way you connected it, you connected all from the same side where the two legs are.
What do you mean by pin 10? You mean analog pin 0, right?
Oh, sorry, yes, I'm pin 0, yes. No, what I said is
I
that
did.
it looked like, Katerina, it looks
Mine
like
is on
your wire
analog
connected like
0.
this, on this side. It has to be connected on the other side, like this. Do you see the screen I'm sharing?
Can you show that again?
Yeah, you're not sharing.
So how you did it, I think it looks like this. You connected all 3 wires from the same side of the potentiometer. Remember, there's a gap, and this row 14 is not connected to this row 14. So you have to go and connect it there. Otherwise, none will work.
But okay.
Does that make sense, Katerina?
Not really, because I still can't see your screen.
You cannot see my screen?
For some reason.
I'm sharing it right now.
I think I do. Yeah, I don't know.
Click on Zoom and see maybe the second one.
Yeah, I am in Zoom.
Do you see my screen?
What do you see in Zoom?
Okay, now for some reason I do. It was taking a long time to load.
Oh, okay.
I got it.
Okay, so your wire is not supposed to be connected on this side. It's supposed to be connected on the other side of the gap.
Okay.
That's because your potentiometer has 2 legs here and another one sticking on the other side.
All right.
So that's how you.
So,
well, can you turn on your camera?
one goes by the little leg then.
Yeah, guys,
Like this?
Because your potentiometer looks different from what's on diagram. Your legs, your pins are not on the same side. One of the pins is actually, it's like the chair, like this, right? And because
Yeah, I
that
saw.
pin is there's a gap in between these 2 pins and the other 2, you have to actually bring the wire from the second part, like on the diagram, okay?
Okay, I'm using a longer wire so it doesn't get in my way.
Did everything correctly.
Here we go.
Okay, can I go to coding?
Yes.
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 Wait, no.
Okay, wait. Don't worry, guys. We won't move unless everyone's on the same page.
That's cool.
Ta-da.
Did I do it right?
Looks right to me. Yeah.
Like, because there's the thing in the back and then there's.
Yeah. No, that's correct. Yeah.
Mine's gonna be flashing red.
9-volt battery.
Who's still working on the schematic?
Who wants to show us their construction?
Ooh, I can.
Yeah, go ahead.
Yeah.
Yeah, looks correct. Yeah.
How's Will and Rylan doing?
Ricardo, you want to
We
show
are
us?
both ready. We're both ready.
Both ready? Excellent.
Both ready?
Yeah, so
Yeah,
I
do you
think
want to? Can you turn on your camera and actually show us?
Is this correct?
Will and Riley.
Katerina, yes.
Set up right, but I
This
think
is
they-
correct.
Okay, good.
Yeah, we all don't have the code except for one that's kind of ahead for us.
Okay, let's go to the code then. You guys have Arduino open, right?
Yeah.
Yep.
Yep.
Okay, let me see.
Just one thing I noticed I want to share, like it's easier for us during the physical class because we can actually come and help, but this way you guys learn more because it clicks more because you actually get to find the things on your own and it actually creates an extra knowledge for you. So there is definitely an advantage as well, right?
Okay, you should all have this code from yesterday.
Yeah, I do.
Yeah.
Okay, so we will be building on top of it. Okay, so what we're going to do here.
So open your Arduino IDE right now.
Yes, open your Arduino IDE, and we're going to be, this time we'll be typing. No more blocks. We're not little children anymore.
Wait, I don't have
Should
it.
I delete the part about the loop that I did yesterday?
If you need the code, need the code from yesterday, I can put it in the chat for everybody to borrow.
Yeah.
Everyone, and I will make like a divider like this. So that,
Yes, Will. If you have the code from yesterday, you can reuse it. If just open Arduino IDE and open that file. It's just like any Word document or Excel document. It's just a file that you open with the program, right? Just any text. So it's just a text document, guys. There's nothing else in it. Once it's pushed to Arduino, it gets compiled and transferred into the machine code, and that's it. That's how Arduino understands it, right? But on your machine, it's just a text file.
Okay, so you can take the code who doesn't have it, take it from the chat window, copy this entire thing, and do you see the chat window of mine? No?
Yeah, and then you can just in Arduino create a new file and copy it there. You can do it that way too, right, Alex?
Yes. So what we need to add a variable. Variables are the things that store different values in it.
Ты пытаешься научить это включать и выключать кнопки, что ли?
Yep. Potentiometer.
Okay, guys. So first thing first, we need to create a value where we're going to be storing the our potentiometer reading, and we're going to call it sensor value because that's the potentiometer is our sensor, and we want to read this value. So we're just going to call it like this. You can call it anything you want. You can call it thingamajig if you want. Name of the variable is not regulated, and it can be anything. You can put Ricardo's value or Ayan's potentiometer. Call it anything you want.
Habit of being a good programmer and name your variable some sensible name so that then you can actually remember what the variable. So your code has to be self-explanatory, right? And a good name for variable that explains what variable does always helps when you read your code.
Huh? Yeah.
Okay, are we all
I can't find the
I'm
int
gonna
thing.
need the sticker.
I don't have this int thing on mine.
You don't have what?
The int thing. Where's the int thing?
Oh, Alex just added it.
Yes.
Yeah, you have to put it in.
I have
It's
added it
integer.
at the end. You guys type along. If you guys will be making mistakes or will be behind at the end, I will share it again with it more.
So now, yeah, so now there's a little bit of coding, so that will involve some typing for you guys, right? Because not everyone come with standard blocks, and sometimes we need to adjust the code. And this is your opportunity to learn a little bit of programming, right? Even if you've never done it.
Yeah, so there is not too many actually differences that we'll be having. So we'll just add one more line and we'll be good to go. So inside the loop, every time there's loop cycles, we want to read the analog pin and copy that value, whatever is on that pin. So we're going to do this. We're going to type sensor value, and we're going to make it equal to the analog pin A0. And how would we do it? We already have digital write command. Very similar to that, there is an analog read command. That looks like this. And we're going to put A0, which is going to say analog 0.
Enter.
So can I ask how many of you actually have experience coding or programming?
Oh, I do.
You do? Yes. Okay. And
I learned Python.
Yeah. Okay. Awesome. So who's never done any coding or programming before and doesn't understand what variable is?
Me.
Will. Okay. How about you, Crancy?
I can't find
My brother doesn't either.
Doesn't either. Okay, so this is not a coding class though, but we'll briefly touch on that. So what is the variable? Variable, Tim, you want to explain that? You're really good at explaining what variable are.
Basically, a variable is a set of actions that you tell your computer to do whenever you say the variable name and sometimes give it a number.
Okay.
Is that correct, Tim?
We will ask Tim to explain it because he runs our Python class. And he's really good at explaining it.
Sure. Basically, a variable is something that exists in most programming languages, right? And here we have it as well in Arduino. If you guys have coded in any other languages, you've probably seen it as well. Or if you've gone in school in math, and you've ever seen like an X or a Y being used in your math equations, that is also called a variable. Basically, a variable is like some kind of box that you will store, some kind of box, like a placeholder that you're going to store a different value inside. And then whenever you want to get that value, you can just say, tell me what's inside of this variable, and you use the variable in your program, and it will replace it with its current value. Right, so for instance, if I have this variable that we have on our screen that Alex just created in his program, he says int sensor value equals 0, right? If we were to ever use sensor value anywhere in our code, so for instance, if we just wanted to know what sensor value was in our code somehow, we were like going to display it on like a little display or something, right? We would say something like display sensor value, and it would be 0, right? And then what he does here in his loop is he's taking sensor value and he's always changing it to what the current reading of the potentiometer is. So when you want to get the potentiometer now, instead of saying analog read, what you can do is you can use the sensor value wherever else you want, right? For a variable, like Alex said, it doesn't matter what you call it. You can call it whatever you want, but usually you want to give it some kind of descriptive name so you actually know what it's storing. And then for the value of it, in Arduino, there's a couple different things that you can store inside of it. Who thinks they know what int stands for? Like at the top of the program, he said int sensor value. What does the int mean? Yeah, so like Ajwad said, it stands for integer.
Integer,
right?
yes.
An integer is basically just a number without any decimals. So for instance, in school, if you've learned like a whole numbers, an integer is just a whole number. Okay. And for this, when you're saying int sensor value, you're saying what kind of variable this is. So if you're saying sensor value is going to hold an integer, you can only put whole numbers inside of it. Okay. There's a bunch of different other types of variables that you can also use instead of, and here is a little picture of some of the other ones you can use.
Well, it's a little bit blurry, but basically in Arduino, every kind of data type requires certain memory inside the chip. And memory in Arduino is super tiny. It's not like our smartphone that has gigabytes of memory that you can store all your videos and music. In Arduino, memory is very limited. There's, depending on the board, it can be up to a few kilobytes, but it's definitely a premium real estate that you need to take care of. So that's why determining which kind of a data type to use for our variables is important. We use integer, and that can be from minus 32,000 to plus 32,000. That's how much space you can store inside that variable. So you cannot store 1 million into that integer. If you want to do 1 million, you have to use float. And of course, if you want to save space, and for example, you know that your variable doesn't go past 100, you can use byte as a type of variable. So instead of int, you put byte, and this will allocate inside Arduino very little space for it, but you will save it for other things, right? Because sometimes you program a sketch that is doing all kind of clever data manipulation, and then you have to manage how much data you can afford to allocate for any task. Anyway, we're using int because we don't care. That's the only variable in our code.
Can you put it back to? Sorry, Will. If you're saying that your sensor value is going to be integer, that means that the value that you can assign to that value should be between 32,768 negative to 32,767 positive, according to this table that's on the screen. Does that make sense?
Yes, but I was going to ask if you can put it back to the end. That, yes.
Yes. There you go. So we're pretty much done in here in the code. All we need to do now is to make sense out of it. Since we have delay right now set up to 1 second, and we want that delay to be flexible, and depending on the position of our knob of our potentiometer, we copy the sensor value and paste it inside those brackets. So now our delay is going to be flexible. It's no longer 1 second. It's going to be whatever you tell it to be by turning the nubbin of the potentiometer. So now this code is ready for execution, and you can just make sure you connected your board to a correct
What?
port, and you press it, push it into your.
I'm not ready.
Okay, give them, yeah, a few minutes to actually.
Oh yeah, of course. I'll keep it in. And if you guys have any syntax errors there, I will share this code in the chat.
So you need to make sure that your code in Arduino IDE looks like this. And if that's ready, select the correct port and push it to Arduino, okay? And we're waiting here.
That code.
Again, the lines that you added to your existing code is line number 1 and line number 8, right? So you basically introduce the sensor value variable as a placeholder, and you actually specified for Arduino that that placeholder can only be the whole integer numbers, right? And then inside of your loop on line 8, you're actually assigning that the analog read A1, A0, sorry, to that sensor value. So obviously behind that analog read A0 is some sort of number, right? And that number is between negative 32,000 and positive 32,000, as we just saw from that table that Alex shared.
Let's go.
Okay, now plug it in. See.
Okay. So I can put it
Okay,
in.
Kranti, how are you doing there, honey? Awesome. Okay.
Why is it wrong?
So do I press verify?
Well, you have to, so after, if you've done the code.
Verify is just to troubleshoot if your code makes sense from syntax point of view, so there are no errors.
Yeah, when
you
you
can do that, but
upload
it's not going to work until you push it into your Arduino, which is.
But yeah, when you click the arrow to upload it, it technically like verifies it first anyway, so you don't actually have to click verify. Verify is like only if you're working on the code without like an Arduino. If you don't want to upload it.
Copy.
If you want to upload it, you can just click the arrow.
So what happens, guys, when you click the upload button, this code gets translated into machine language into zeros and ones that then being pushed to Arduino. So verify kind of does like high level compilation just to see if that process actually doable, right?
Yeah.
Mm-hmm.
You know how to copy, right? So you.
Alex, my thing isn't computing. It just keeps saying error and message.
Can you share your screen, please, Ajwat?
Okay. Okay. Okay, let's try this again.
My code only did nothing except the light blinked only once.
Here it is. It's just not computing.
Is this? Oh yeah, it did the same thing.
Sensor value was not declared because your spelling of your sensor value here on top is different from sensor value inside the loop. Your top says sensor value and it says sensor value.
You have a little
so keep it the same. The correct one was actually inside the loop, but it doesn't matter as soon as you correct it. Now run it.
No, Ajwat, it's still Cessner.
Cessners, yeah.
Did I
press extra S before the N?
I suggest to copy it from one place and paste it on the other, so they will be.
Ajwat, you have an extra S before the N in the loop.
For
You
those
just copy paste it because I don't.
For those calling, guys, your sensor value variable name should be same on line 1 and 8. So you basically told you introduce the sensor value placeholder to the program, and then you're not using it if you're using different, right?
Yeah. Okay.
Just wait.
Yes.
Is it correct now?
Let's see.
It's not working well.
No, it's just
digital right and high. High is supposed to be capital.
Oh.
Wait, what does it mean by serial port not selected?
All high letters should be capital, just like low, right?
Then I plug them all in.
Serial port is the same thing Arada was talking about before. Not capitalized, capital, all letter capital. It's a service command, so it's supposed to be the same as the low. Is all letters supposed to be large?
Yeah.
Oh, okay. That makes
Guys,
sense.
yeah, here where you have to be meticulous.
It's
'cause,
supposed to change color, you see? High now, it's blue, so it's supposed to
that
work
kind
now.
of helps you, right?
Also, it has to be like the same as each row as well.
Yeah, just push it in now.
Let's see. This should work now.
Yeah, now it's compiling, right?
Yeah, now it's compliant.
Right.
Did I do this right?
Did you get it working?
Ian, if you turn the potentiometer, it should change the way
Yeah,
that
perfect.
blinker.
I think it did, right?
Would be helpful.
You need help, just turn it, start getting into this.
It just regulates how long it actually lights up, right?
Do I press upload?
Yes.
Yeah.
Make sure your port is correct. Remember that trick? Yeah. In tools, under the tools, make sure you're selecting the correct port always, guys. That's a step you always have to check.
Download it from here to here.
Yeah, I helped him a whole bunch.
So Ian, did you push your code into your Arduino? Because
Yep.
it's hard to tell for me if your frequency of blinking is. Oh yeah, there you go.
Put it in. It's super flashing.
Yeah. So it's not very very smooth. It tends to be
Whoa.
reacting on the potentiometer in one end of its diapason.
It's like a star. Mine drank too much Gatorade.
Mine isn't working.
Mine is just going.
The light's just on, like it's like. As though it's without code. I've tried uploading it 2 times.
Okay, mine eventually
doesn't
slowed
work.
down.
Yeah, mine's working.
Mine's not.
That's okay.
It's not working.
Do I do now? Is it supposed to say something in like the bottom?
It's not supposed to say anything in the bottom if there's no errors.
Okay, yeah, there's no errors.
And updating.
It said Sketch uses what a blah 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 bytes 3%. Yeah.
Wait, what? Like, what does this thing do anyway? Like
Yeah,
the
it's something.
analog. I mean, the potion.
I still can't find the.
So let's go through the code, guys. So sensor value, initially we establish the variable. We're gonna say this is a box with the value, sensor value written on that box, and we put 0 into it. So there is nothing in it until we populate it. Then we're saying on pin 10, we're gonna be using it as an output for our LED blinker, and then we go into our main loop.
Yeah.
First thing we do in our main loop is we read the pin A0 on Arduino, and whatever we read from it, we toss it into the box that has sensor value written on it. And then we just address this box from our delay function. So every time we ask for delay, we're saying we want to delay it not for a second or half a second, we're gonna delay it for some unknown value yet that we will read from our potentiometer. So the second thing I wanted to show you today is how to actually see what we actually reading from that analog pin. Because often we either connect it in a way that it doesn't read right, or we would like to just calibrate our circuit in such a way that we get expected return. Because right now I see that most of my blinks concentrated on a very narrow window.
What did you use, Will?
Okay, so for this kind of thing, there in Arduino, developers have invented a thing that's called console, and we're going to be touching on that right now. Console is the you see there is a little magnifying glass. It's called serial monitor in Arduino. If you click on it, it brings up the blank screen, and there is nothing in it. But what we can do is we can actually read the value in our Arduino and push this value into that screen so you can see the digits, the numbers running on the computer, what Arduino sees on its pin. Okay, so how to do it?
Magnifying glass.
How to do it?
What magnifying glass?
Magnifying glass on top right here. It's a serial monitor.
Oh. On the Arduino.
On Arduino IDE, yes, exactly. So we need to add 2 lines of code. One line of code would be, we need to establish which speed we will be reading our serial from Arduino. And that's called serial, just like our breakfast. And we're going to begin. And we're going to put a speed. And usually it's the slowest one you can do is 9,600. And the second line of code that we want to add is we want to print into that window the value that we read from our potentiometer. How to do that? We go serial, and we're going to print ln, meaning that there will be on a new line.
Can you just copy those and then put them in the chat again?
Oh, of course. I just want to type it and show you and describe as I'm typing it. Now I'm going to put it all in the chat. Ricardo said, help, help, help. Ricardo, what do you need help with?
I can't find the potentiometer thing.
Oh, can you send him to the breakout room with Tim?
Yeah, absolutely. Give me a second.
Okay.
I'm going to put you to
Bring him up
breakout
to
room.
speed.
Tim will troubleshoot you, okay?
Yeah. Anyone else need help, guys? We have 4 instructors, guys, for 9 of you. So each of us can literally take you, like a couple of you, and take you to breakout room if you need to.
Okay.
So make sure to use this.
Ricardo, please accept the breakout room and you will join with Tim.
Sensor value.
Excellent.
Everyone else up to speed? You guys need any help?
Yeah,
Good.
Please don't keep silent, because at the end we'll ask you to actually see your working contraption, right? So
My light is actually, like, the potentiometer is still not working.
still not working. Okay, can you share your code, please, with us? Can you share your screen?
Sure. I actually did what Alex put, but before that it wasn't working, so I don't think that right now it will work.
Oh, you have the code?
Yeah, I got the code, but the light won't blink, so.
Yeah, share your screen, please, with us.
Oh, sorry, wrong one. This one. And it actually is still not working, like.
Sensor value, done upload.
Gonna try to upload it again, but didn't work last time. So I don't think. Yeah, it's still not working.
So you mean it's not blinking correctly?
It's not blinking at all.
It's not blinking at all.
How is it supposed to blink?
Is your LED connected to the pin 10?
If I take my sensor thing out, it'll just keep blinking at the same pace. It just keeps blinking randomly, I think.
Well, did you install the knob?
Oh,
Yeah, you don't have the knob to
can you
control
put that nubbin into the potentiometer and spin it?
Yes, I did. It's
What
not
is
really,
the sensor
Yeah,
supposed to
put that black nubbin, plug it into the potentiometer, and turn it a little
So
bit.
you're supposed to control it, right?
My
Yeah.
light's wearing out.
changing at
Now
all.
spin it.
I don't know if it.
Is it blinking?
Yes,
Nope.
it is.
It's just staying the same.
Okay, we're looking at Katerina's code right now. Yes, it's Katerina's sensor value 0. Oh, let me see that. Katerina, can I request remote control?
Okay.
And Will, at the meantime, can you turn on your camera so we can troubleshoot you next?
Katerina, do you see the serial window that popped up?
Yep.
Is there any numbers on it as you spin the potentiometer?
Yes, it's 1023.
And as you spin, does it change?
Yes, it does.
It does change.
But the light doesn't blink.
Safety goggles while we're doing this.
You have them in the garage. You could go and get them.
Can I look at your schematic? I think your LED is connected directly to power.
Sure.
It's not connected to pin 10.
Feel free.
I'm confused. What is the sensor supposed to do?
When you turn on the knob, it will control how long your LED stays on before it turns off. Like before we had it.
Wow, that is
a delay at this one millisecond interval. Like at this.
Oh, that's cool.
Yeah, right? Does it work?
Yeah.
Yeah, so now instead of this setup interval of 1000 milliseconds or whatever it is, the number there, right? It actually, we're using that sensor value variable, which basically controlled by your knob, right?
Yeah, that's cool.
That is so cool.
So guys, right now, if I'm to push this code to my Arduino with all this serial print values, you see done uploading. If I call this magnifying glass, do you see the numbers running on my screen? It's saying 58. So if I move my potentiometer nubbin, the peg, my value goes from 1000 to a 0. I'm not sharing screen, am I? Share screen here.
Can you show us how to do that again?
So you see, if I'm spinning the potentiometer, this values change on the screen. And this window I called by pressing that serial monitor magnifying glass on the IDE. There's another window here, but there's nothing in it.
So I plugged it in and everything, but when I turn the thing, the serial thing is not working. Like how it's like that.
So when you press it, it doesn't show anything?
Yeah.
Did you update your code with these two lines, serial begin and serial print?
No.
You need to update it because that's what it makes it possible. Those two lines, this line here, serial begin, and this line here, actually print that sensor value onto the serial monitor on the computer. So you can troubleshoot what your potentiometer shows.
Okay. So what am I supposed to do exactly? Because it still ain't blinking.
You need to go to your breadboard, Katerina, and try to see. Emily, you want to troubleshoot Katerina's circuit? I can put you in a separate room.
Sure. Do you want to send me the code that we're working with, and then I can try to see what's
It's
going on?
in the chat, Emily.
Ah, perfect. Thanks.
But the Katerina's code has no troubles.
Okay, so we're just looking at the circuit?
You just need to see if the LED is connected to the correct output pin, which I suspect is not.
Let's see.
So let me look at the breakout rooms.
Also, Tim's back.
Tim is back.
Oh, okay. Tim can take Katerina then.
What happened?
Can you help Katerina troubleshoot?
Katerina, yes, Katerina. Katerina, I assigned both of your devices to a breakout room, and either Tim or Emily go in there and check it out. Check her correct code, but it doesn't blink.
What happened?
I'm just going to send you what code you let me have it back.
Rylan and Will, how's your circuit doing? Did you guys manage to make a controllable frequency of blinking?
Yes, it is, and I have it showing on the.
Oh,
And you have showing on display. Excellent. So this is you cannot overestimate the importance of that serial monitor. Serial monitor is the most effective way to troubleshoot readings of your Arduino. So anytime you use any sensors and you need to find out what those sensors are actually showing to your circuit, this is the way. You bring that window in and you see what numbers your sensor is. So if you're reading temperature, for example, and you're trying to make a home automation, whenever temperature increases, turn on the fan. So that value at which your fan turns, you can troubleshoot by just going into your console, into your serial monitor, and read what your temperature sensor currently reading, and then pin the position where you want that action to happen. And we still have half an hour, so I suggest we can actually go ahead and try to play with the photoresistor, because photoresistor is super exciting too.
Before we do that, can we make sure that everyone's actually on the same page?
Yes, I think everybody's done. Yeah.
So can I see everyone's contraption? Ian, you said yours works, right? Yeah, yours works. Ian, how's yours? You can control it, right?
Yeah.
Yeah, good job. Clancy, how is you doing? And control work. When you actually regulate the knob, does anything change? Can you try that, Clancy?
I'm good.
You're muted, honey. Can you unmute your microphone? Yeah.
Can you say that again?
So that knob, that's potentiometer that you just added, that's supposed to regulate how much intensity of LED blinking is, right? So when you actually turn it, then does it change the LED light at all?
Yeah, it does.
It does. So it controls it. Perfect. Good. Ricardo, how are you doing?
Yeah.
Fine. Can you zoom in a bit?
On what? On the circuit?
On the breadboard, quick. A bit.
Yeah.
We got it.
Okay, guys, and remember you have access to Alex's project on the Tinkercad. All you need to do is just go to Alex's folder.
Yeah, if I'm doing something and you really need to look at the circuit, you feel free to go to Tinkercad, open up the project that called Alex, and you will see the connection on your screen.
So that's the beauty of online class, that we all have access to the same folders and we can see the same screen, right? So feel free actually to utilize and use this advantage.
Oh, Irana?
Yes,
I don't think mine works right. It only changes the dimness and stuff when I push it down, not turn it.
Okay, can you, well, you just copy pasted the code, right? So I'm assuming your code
Assimilate.
is correct.
Yeah.
Okay.
Assimilate.
Maybe it's not plugged in properly. Just try to see if all the legs of potentiometer are firmly in and all the wires that connect into it are firmly in as well.
Yeah, so it's just two things. If your code is right, if you copy pasted it from Alex's, then it means that some wires maybe are not going to the right.
Tinger this.
So this is test of your find I don't know 10 differences, right? The skill. So
okay, so guys, if you break your potentiometer, I don't advise you to do it, but if you would, then what are you gonna see? You're gonna see like one leg. Well, let me get the thicker line. You're gonna see one leg, another leg, then you're gonna have like a little round kind of a track, and the center pin has a wire touching this little path. So when you spin your nubbin, this wire goes to the left or to the right. So if you have ground connected on...
Okay, now it works. I just didn't put it in right.
Yeah, if ground is on one side and plus 5 volts on the other side, so, and then you're trying to sense what your center pin is going to be reading. So you take your wire and you connect this pin over to your reading pin on Arduino. So in this situation, if your handle is all the way on the left, how much your pin is going to show in here? Who can tell me? if you take this nubbin and you put it all the way to the left, how many volts that blue wire is going to show on the pin 0? Who can guess?
Yeah, back on it for some reason.
Anybody? Take a step.
0.
0? That's correct, because once this wire touches ground, there is no electricity going through. So what you get on your blue wire is 0. So now, if I'm to take this thing, where is my pen?
Real modern.
কোথায় যাবে?
Trying to get out.
তুমি কি করবা?
If I take my pin, I turn it all the way to the right, what's going to be showing on my blue wire? Anybody? If I take my potentiometer and I spin it,
Like 1,000.
All the way to the 1,000?
Yeah, my guess.
It's not working.
Well, it is correct and incorrect. Actually, it's going to be 5 volts still, but how the Arduino works, when it works with analog things, it's actually digitized it into a discrete value. So it goes from 0 to 1,000 plus something. So let me stop annotating here and call my thing, and I will bring it all the way up to the right. It's going to be 1,023. So it takes values from 0 to 5 volts and breaks it into 1,023 little divisions. Okay, so when you're reading 5 volts, your actual sensor value will be 1,023. If you go all the way to the left, your value will be 0. But in physical terms, you're reading between 0 and 5 volts. So let me minimize this thing. Yeah, and of course, if anything in between here, where my annotation tool, anything in between, of course, would be if we just go and draw it like right in the middle, it's going to be 2.5 volts, medium value, and your A0 pin will read somewhere around 500-ish. Okay.
Okay, so you're okay now?
What?
You're okay now? I see you guys are back.
Yep. It's blinking.
Good. Okay.
Okay.
Okay, so
How do you get onto the serial thing again?
You want to go back to the serial? Sure.
It's not letting me get on it.
The little.
Okay, Ricardo, can you please use the Tinkercad and open that diagram? And please stay after the class. We'll catch you up, okay?
Me?
Yeah, Ricardo.
Yeah.
Okay, I see you're falling a little behind. So open the Tinkercad diagram on your own. Go to Alex's project there, okay?
Okay, wait.
Are you in the Tinkercad?
What did I miss?
Okay, because we're gonna move.
Are you talking me or not?
Who is talking?
What
now?
did I miss exactly?
Guys, if you're not talking to us, can you please mute your microphone? Because otherwise we'll have too many students talking at the same time. Yeah. Only unmute it when you talk and when you need help from us and you actually want to talk to us, okay? So Ricardo.
Yeah.
Yeah, everyone else is pretty much done with this, and I see you falling a little behind because you had trouble finding the potentiometer there. I want to make sure you actually see the diagram while we move on. Can you please open Tinkercad on your computer?
Yeah,
And go to Alex's project there. Just click on the Rubik's Cube on the Tinkercad logo. And when you see all the folders there, all the projects, select the one that says Alex on it. Okay?
Oh, wait.
Okay,
Yeah,
and I'm actually going to, oh, somebody really messed it up. Are you guys trying to play with my project there?
Okay, wait. So I'm on a page that says 3 design circuits, code blocks, lessons, and then a bunch of different numbered projects.
Yeah, so when you're in the Tinkercad here, you need to go to circuits right here on the left.
Yep.
And when you click circuits, you will see all those Arduino circuits that you guys have put together. Just look for yours. If you have made yours,
No,
Ricardo, this is a
yours.
Ricardo one here.
No, Alex, you need to look for yours.
He needs to find mine.
Yes, because you want to follow your diagram and you keep switching the windows.
Yeah, yeah. Then just bring up the Alex one, and I will actually create new circuit, and this one will be used for our light sensor. So I'm gonna drag this guy.
Call it light sensor or something. Yeah. And Ricardo, were you able to open Alex's folder?
What's his? I clicked circuits. And
okay. Tim, can you Alex, can you put me and Ricardo in the separate room, please?
Yeah, yeah. Give me a second. Errata assigned. Breakout room. Ricardo, you can join breakout room yourself because you're still in it. You still have it. Just select the breakout rooms and go into it. Errata will meet you there and she will help you.
Wait. Oh, wait.
Alex?
Yeah?
Can you help me?
Yeah?
I can't get back onto the serial thing.
You mean you cannot call it in?
Yes, I keep pressing the magnifying glass and I can't get it.
See if maybe it's behind it. Just try to minimize all windows, move them around, and see if that window is somewhere behind.
I tried that.
Wait, how do I leave and go to the breakout room?
You go to the menu, select breakout room, and select join.
No.
Okay, Ricardo's there. Now, Will, you said you lost the serial monitor.
Yes, and it's not letting me in. It says board at...
Try to restart Arduino. Close the Arduino IDE window entirely and then bring it back in.
Okay.
It could be that that your Arduino isn't connected.
No, it's still gonna bring the window.
Oh, but that's what mine did, so I don't know.
They're just helping somebody get it.
Is your Arduino plugged in, Will? Is it showing some signs of life? It has LEDs on it. On?
Alex, just let him share his screen and we can take a look.
No, I'm not allowed to. My dad won't allow it.
No, not the camera. You can share your screen.
Oh.
You can't? No?
Go to breakout room.
Here, I'll try then.
Okay, you're inside Tinkercad, so you need to minimize that window of a Tinkercad.
So yeah, click on the Arduino thing at the bottom, or just minimize this.
Minimize it?
Yeah.
Okay, just click Arduino. Okay, and then click the magnifying glass.
Oh, it says board at null is not available. Select tools.
Oh yeah.
Tools.
Is this the right one?
Yeah, yeah. Select the tools on top. Tools. And then select port. And then select COM7. Yeah. And now click magnifying glass again. There you go.
And it's not blinking anymore.
Well, it's showing you some value. Try to turn the nubbin. There you go. You can change this value. There you go.
No, but the light's not blinking.
Light is not blinking. Can you close this serial monitor? Close or minimize or move this window away. I want to see your code. Or click on Arduino window underneath. Yeah, click on that window underneath. Yeah. Okay, now you see your code is obsolete, it's old. It's either you probably have another window there that has a correct code in it. Can you click on Arduino here? Select that, click on it again. What is this COM7 thing? That's probably the serial monitor. Yeah. No, your code is old, so it's only blinks for 1 second for 10 seconds. I don't know actually how it happens that your COM is reading potentiometer, but the code is not. Can you go to File on this window that is currently on? Click File, and then Open Recent. Sorry, Open Recent. Yeah. No, not Open. Open Recent. Yeah, this one. Oh, you have only one there. Where is all the information gone?
You need the serial thing.
So I suggest you to actually go to Zoom and then copy the latest version of the code from there with the sensor value and serial print ln, all those things, and paste it into your window so that you have the latest code. Because right now you only have basic blinker code.
Where is it?
I don't know. I cannot see your Zoom window, but if you click on Zoom, you will be able to go to chat, and from chat you can copy it.
And it's in there.
Do you see the chat?
Yes, I have it up.
Okay.
And Dhruva said, finalement, ça marche. So I will give you the potentiometer as a homework for tomorrow. So you're going to have to do it yourself. I'm going to do the schematic, but the logic would be the same.
It's still not blinking.
Okay, do you have to upload it now? Push it to the Arduino.
Yeah, you need to upload it.
Do I need to go in the tools again?
No, you go to this arrow.
Do I need to put it in the tool thing again though? Like, do I need to go into tools and then put the, go to the port and then?
No. Once you have selected your port, you don't have to re-select it every time. It only happens once when you like start your Arduino. Sometimes it's not automatically detecting your board. So you have to go to Tools, Port, and select the correct one. Once this is done, and you continue working on your code, you don't have to revisit it at all.
I got it.
Excellent. All right, so let me now share my desktop, and I will show you how I'm going to do the exercise with the photo sensor. So I'm going to put back my LED. This guy is going to be called photoresistor. I'm going to call it Alex Photo Sensor. Like that. So you can actually go after the classes over to Tinkercad and steal things from it if you want. So here is red, and I'm going to connect ground to my ground. Usual setup. Okay, now I'm going to have a resistor connecting to my short leg, and I will connect my long leg to the pin number 10, the same way as we did it. And I'm going to change all my outputs, it will be blue. Okay. Resistor is, I will use it 100 ohm. And now the photoresistor. Photoresistor, here it is. I'm going to bring it in, rotate it a little bit, and put it in here. One leg's going to be connected to here. Then I need a resistor. And this resistor will be 1 kilo ohm is fine. I'm going to connect it to red, like that. And this point will go to our pin in A0. So you guys welcome to borrow schematic and build it in. And this is going to work exactly as the potentiometer, except how it's going to work is going to sense the outer lighting. Okay, so what you can do to interact with it is you can just cover it up with your hand, and it will change resistivity as the resistance change. Right, can you open the door? I think it's FedEx. Yeah. So when you cover the sensor, you're going to see a resistance of that sensor change. So this schematic works as this. Let me show you. Annotate, draw. So it's like a garden hose. So if I have like a faucet with the opening, and I have a garden hose going in here, and on here the water is flowing. Okay, this is my garden hose. I have a little hole in the middle of this garden hose, right here in the center, and that sprays the water up in the air, like this. So imagine now that this section of the hose on the left is a regular resistor. And this section is a photoresistor, but photoresistor acts as if it's a little person, a little fat person, actually putting a leg on the hose. So if I'm to like put my leg on the hose here, what will happen? There will be less voltage coming on this side and a huge fountain of water coming from that hole because the water has nowhere else to go. Okay, and then if I lift my leg in here, I'm gonna have this fountain go down because will be less resistance and some of the water gonna continue down the hose into the opening of the tip of the hose. So this is basically the same as that schematic that I just built. I have plus 5 volts in here. And then I have ground in here because all the water spills out to the ground, right? Then I have like a simple resistor, which is just a section of the hose. And here's a hole. And from here, and from that little hole, I'm connecting to my analog pin, A0, to read how much of that fountain is in the air. So the taller the fountain, I can say it's darker it is, and then the lower the fountain is the brighter it is. You can calibrate your own circuit after, once you do the reading, and put it in your serial monitor, you see that value. You can do adjustments, you can do math and things like that. So if I'm to, for example, to adjust my frequency of blinking, I can change my analog read and divide it by 2 or multiply it by 3 if I want to maximize the effect of that value. Do you get how it works? More or less? I don't know if that was good comparison, but I think it's very obvious. So if you have a garden hose analogy with the little hole in the middle and a person squeezing its foot on that hose, this is the effect of the photoresistor working in that bridge schematic. So if I'm to go in here, this is your bridge, right? So electricity goes like this. It goes from the plus through a resistor, they holding hands with the photoresistor, go through photoresistor and come back to the ground. And that place when they holding hands here, this is that proverbial hole in the garden hose. From here we got sprinkling water. And that's what we're sensing with this wire. We connect this wire to the place when they holding hands, a regular resistor and a photoresistor. And we put this thing into our analog pin A0. And that's gonna work exactly as your potentiometer. So I will leave this with you guys today because we're like 2 minutes away from closing the class. You're gonna build it yourself. You feel free to go to Tinkercad after the class and use my schematic as an example. Build it in, and the next class tomorrow, we start with reviewing that circuit and seeing if we made it work. Sounds good?
Yep. Thank
Okay.
you.
I believe in you guys. I'm sure you will be able to make it work. And
Yep,
again,
thank you.
the photoresistor looks like this little thingy. There are two of them in the little bag. This little plastic bag.
So are we supposed to build it?
Yes. Use that schematic that I just shown. You can unplug your potentiometer, and instead of potentiometer, you use the a collection of 1K resistor and one photoresistor together. You don't even have to rearrange the wires much.
There's one thing that says remove seal after washing.
Seal after washing?
Yeah.
Where? You're not supposed to wash anything in there.
I know, I'll just show you in a second.
There may be a humidity sensor. That's maybe what is it for. Because there is a guy here that is a humidity sensor. This guy, the blue. Maybe it refers to that guy, but I don't see it.
So are we supposed to build it like after this?
Yes,
Or are we
it's a homework for you guys.
Okay.
Nice. This kit even has a relay, so you can actually control large apparatus like tabletop lamps and grinders or garage opener. Very nice.
Alex?
Yes.
I can't, it's not working. I've got the same setup as you have there, and it's not working.
For what? For the potentiometer?
Yes.
Can I go?
I don't have the coding though yet. Do you need a specific coding thing?
This is Will?
Yes.
Okay, so you said you put potentiometer code in it, you upload it, and it doesn't control the blinking?
You have to copy the potentiometer coding.
I have to go.
You put it in the chat?
Yeah, guys who finished, please, you feel free to leave right now. And the guys who need help, you are welcome to stay behind, and I will try to help. So I will just go right now with Will, and we'll get this thing done. So let me do this. Let me.
Thank you. Bye.
Bye bye. See you tomorrow.
Bye. Thank you.
Thank
Bye-bye.
you.
This is Alex. Just a second. What I'm gonna do is I'm going to go to code. I select a text, and I'm going to paste the code from my IDE into that window so that you guys could borrow it from there. Okay?
Is that the right code?
Yeah, this is the correct code.
For the...
So now, Will, let's do that. I will stop sharing. Will, if you can start sharing your screen, I will troubleshoot your code.
So... I need... Okay, share screen. Screen 1. Screen 1 or screen 2?
The whole desktop. If you have like a laptop, if you use desktop with the 2 screens, it doesn't matter which one. I will ask for your help to. Yeah, okay, that's what I need. So this is the correct code, as far as I can tell.
This one here?
This one, sensor analog read. It doesn't have serial monitor. So if you would like.
No, I want to do the.
If you can authorize my remote control there, I'll show you how to steal the stuff from my code there.
I want to do the.
Yeah, that's what he was trying to show you, is the photo sensor. Come on.
Yeah.
Oh, you want to do the photo sensor?
Yeah.
Okay. Okay, let's do that then. It will be the same code as with the potentiometer.
Okay.
But you will need to build the schematic based on what I have put together for Tinkercad. So you need to go into Tinkercad. You just can go yourself into that Rubik's Cube. Click on the Rubik's Cube. And then find the Alex photosensor sketch here on the left. Yeah. Click on that. No, you went too far. You went too far. Go up again. And it's right there on the left top. Yeah, click on that. And click Tinker this.
We had to pull it out because I couldn't. I wasn't using the pliers. I just used the pliers to pull it out of the board after it broke.
There you go, Will. So now you can look at this schematic and build exactly the same way. There is no code difference between potentiometer and this. So whatever you have
It is the same thing
right now, yeah,
it is the same.
Was that?
I've got it I've got it like that.
You got it built?
Yes, I have.
Okay, so right now, what you want to do then, you need to go to your Arduino. Your Arduino IDE, yes, this one. Open up the code.
This one?
Yes, yeah, this one. And now run this code again, upload it, click upload button. Okay, now open up the serial monitor, click on that magnifying glass. Okay, now try to cover with your hand the photoresistor.
Like pinch it?
No, just put your hand on top of it.
Block the light.
It doesn't seem like the sensor is reading much. So what kind of resistor did you use for that the one that is holding hand with photoresistor? Which value?
220.
You need to use like 1K, I think, at least, or maybe more. So try to replace that resistor with 1K and see if it makes difference.
Do I need to replace both resistors, or
no, only the one that's holding hand with the photoresistor? The one that is connected to the LED is fine. It's supposed to be. It can be 220.
Yeah, but the light is still not flashing.
Because currently your sensor value is 0. Your light will be always on right now.
It's not on. It's not on.
Okay, then we need to troubleshoot your schematic. So
no.
You had it backwards.
You need to look at how you built this thing. So to check that.
It's on now.
It's on now.
It's on?
It's on. It was just backwards.
So yeah, basically right now your sensor value is showing 0. That means that your delay is 0, meaning that there is no delay and it's always between on and off. So it will be like glowing with half capacity. It's not full brightness, but it's not completely off either. Okay, so now we need to make sure that your sensor value is adjustable within reasonable range. So what you need to do is you need to find the resistor from the pack and find the one that says 1K and try to use that one and put it in the position that is next to the photoresistor. And I want to see actually that 0 change to something. There you go. You get 800, 700. So you should have some sort of blinkage of your LED right now.
I do.
Okay. And now this value is supposed to change with the lighting around your photoresistor. So if you like bring it to a light and like touch it with your finger, for example, you should see the value change. Try to touch it and then remove the finger. Touch it, remove the finger, and see if that affects the value. So is it currently covered with your hand?
It's currently covered right now.
Yeah, it's not changing.
Now remove your hand. Then you get 500.
Oh!
You got some sort of difference, right? You don't get a very wide range. You get between 800 to 500 range. So for 500, it's completely bright. So try to like shine on it with your, if you have a window nearby, point it toward the window. If you have cell phone with a flashlight, get the flashlight on that photoresistor. Do you see the difference?
Yes, I see.
There you go. That's the effect of the lighting around the photoresistor. So when it's completely covered, your value goes very high and your LED blinks slower. But when it's really bright around it, your LED goes super fast. Right? And the next class, guys, we will introduce some if logic so you can actually set up the evening conditions. So we're going to call some values at daylight, then we're going to call some values at night, and somewhere in between would be a medio like evening when your light's gonna come on, and we're gonna work with that. Okay.
Okay.
So for now we should close because it looks like you got it under control.
Okay.
Excellent. All right. So good job today.
Bye.
Bye bye.
My brother's still in.
Okay.